Welcome back, student. Now, this is the equivalence relation. A relation R is said to be equivalence if it is reflexive relation, if it is symmetric relation, if it is transitive relation simultaneously. A relation should be reflexive, symmetric, and transitive at the same time. Let us take one example. Let L1 and L2 are two straight lines. L1 and L2 are related if and only if they are parallel. They are parallel. Now, any line is parallel to itself. So, L1 and L1 are related for every L1. If L1 and L2 are related, it means L1 is parallel to L2. So we can write L2 is parallel to L1 as well. That means L2 L1 are related. Now take L1 L2 are related. L2 L3 are related. What does it mean? This means L1 is parallel to L2 and L2 is parallel to L3. So L1 is parallel to L3. L1 L3 related. L1 L3 are related. Now here we get reflexive relation. In this step we get the relation is symmetric, and in this step we get the relation is transitive. So this relation is equivalence relation. Okay, coming to the next problem. Not problem. Now one more example. This is from NCERT book. A relation R A X is a book, in a library. We are defining a relation R XY such that X and Y have same number of pages. Same number of pages. What do you think? Will this relation be equivalence? will this R be equivalence relation? Take this as your homework. I am quickly saying it. XX will be related because X and X will have the same number of pages. If X and Y are related, then X and Y are having same number of pages. Y and X will have also, and similarly you can prove the transitivity. So that will be equivalence, but you have to do in your copy and you have to submit. Okay, we are taking one more example. Do you think, let A X is human being, now we are defining a relation R, XY. X and Y are friends. Many thanks that you have submitted your homework yesterday. But one little flaw in it. Okay, let's see. X and X are friends because every human being are friend of itself, himself or herself. Okay, X is always friend to X. Sorry. Let us take X, Y belongs to R. So X is a friend of Y. It implies Y is a friend of X. Now take one more, XY, YZ belongs to R. That means X and Y are friends, and YZ belongs to R. Y and Z are friends. Is it necessary that X and Z are friends? No. Take any example. Let X resides in India. Y also resides in India. But Z lives in US. Do you think that X and Z will be friends? Not necessarily. So this relation is not transitive. This doesn't imply that X and Z will be friends. So this relation is not transitive. This is reflexive. This is symmetric, but this is not transitive. So friendship is not a equivalence relation, not transitive. Okay, so friendship is not a equivalence relation. This is very important. Now one equivalence relation is defined in the set A. in the set A, one equivalence relation is defined. Now, what will be the effect of this equivalence relation on the set A? There will be some element which will be related to a specific element A. This specific set is said to be the equivalence class. This is the equivalence class. Equivalence class of A, what does it mean? This means the set of the elements of A which are equivalently related to A. Let us take one case. Let the relation R is defined on the points. Okay, this is one more problem. You should read first how the relation is defined. R is R is the relation between 2 points P and Q such that distance of P from origin is same as that of Q from the origin. That means P OP is equal to OQ, where O is the origin. Okay, can we write OP equal OP? So P and P are related. So this is reflexive. For every P, if OP equal OQ, it implies OQ equal OP. Now OP is equal to OQ, that means P and Q are related. OQ equal OP, that means QP related, so that is symmetric. Now if OP equal OQ, that means P Q are related, and Q are related. R is another point. R is not the relation. So don't take R, take S. Oh, sorry. OQ equal OS. That means OP equal OQ and OQ is equal to OS. It means OP equal OS. So P and S are related. P and S are related. So that is transitivity. Though, so this relation is transitive. Yes. Now you will understand better if I take one circle. Yes, that's it. Let us think that this is origin, this is origin O, you can take it O. Let this is P, OP, let this is Q, OQ are equal, and let this be R. Now if OP equal OQ and OQ is equal to OR, so OP is equal to OR. So how many points will be related with P? Actually, all the points on this circumference will be related to P. Am I right? So now if you can collect all the points which are equivalently related, because this is an equivalence relation, if they are equivalently related, they will form a set, and this set is known as equivalence class of P. Now this is the definition of equivalence class. This is the definition of the equivalence class. Equivalence class of A is all the elements of A. If the relation equivalence relation is defined on the set of A, all the point X which are equivalently related to A. This is the equivalence class of A. So here what will be the equivalence class of P? Can you write equivalence class of P? All the points S, sorry, this point should be S. All the points S such that OS is equal to OP and S obviously belongs to the set A. So that will make a circle. All these points will make a circle. That is one question from equivalence class. I hope you have understood the concept equivalence class also. Okay, now there are two more problems. The first problem is very important also. Okay, let us try to solve. Read the first question. N be a positive integer. Prove that relation R on the set of integers defined yes, x minus y is divisible by n. Let us solve it. At first we have to prove or find whether this relation is reflexive or not. X minus x is equal to 0. Can we write it? So x minus x is a multiple of n. As what is the definition of divisibility? A number p is divisible by q if p can be written in the form of kq, where k belongs to the set of integers. That is the definition of divisibility. X minus x is equal to 0. That is equal to 0 into n. So xx must be related. So this shows R is reflexive. Now let us suppose xy belongs to R. That means x minus y is equal to k into n, where k belongs to the set object. Y minus x is equal to minus time k into n. Now what is minus k? What is k? K belongs to z, so minus k belongs to z. That means yx is related. This shows R is symmetric. Fine. Now xy, let once again xy belongs to R, yz belongs to R, x minus y equal k1n, where k1 belongs to the set z, yz belongs to R, y minus z is equal to k2 into n, where k2 belongs to the set z. Now if you add it, both these, y and y will be cancelled out. That will be x minus z equal k1 plus k2 into n, where k1 k2 belongs to z. Now k1 plus k2, k1 is an integer, k2 is another integer, k1 plus k2 will be also integer. So x minus z is a multiple of n. So you can write xz belongs to the set R. X and z are related. This shows R is transitive. So this is equivalence relation. Now you have proved the equivalence relation. Now this is what we have in our question, but we are going further into the problem. This is additional part. What will be the, if n is equal to 4, what will be the equivalence class of 2? Do you have any idea? Think. 6, 10, 14, so on. What will be the equivalence class of 3? 7, 11, 15. What will be the equivalence class of 4? 0, 4, 8, so on. Here you will have 2 also. Here you will have 3 also. What will be the equivalence class of 1? 1, 5, so on. This is just the extension. The second problem is almost similar. Xy, modulus of x minus y is divisible by 4. This is almost similar. This is given as a homework. You can solve it on your own. If not, then you will write in the comment section, or you can send in WhatsApp number. Okay, this relation is equivalence relation. Now this relation is generally known as congruence modulo n. This relation is congruence modulo n. I should tell something more on this. Actually, two integers x and y are said to be congruent to each other. This is not congruence of triangles. Two integers are said to be congruent to one another. X is congruent to y modulo n modulo 4 if both leaves a remainder, the same remainder when divided by 4. I am repeating, x and y are congruent if both leaves same remainder. If both leave same remainder when divided by 4. Just take an example. 2, 6, 10. When you divide it by 4, it will leave a remainder of 2, it will leave a remainder of 2, it will also leave a remainder of 2. Now fit this. How x and y are related? X minus y is 4k type. X minus y is divided by 4. So this is congruence. Okay. Now coming to the next problem. This is the next problem. This problem is not in the usual set. Relation is defined on n cross n. How a typical element of n cross n will be? That will be ordered pair. Now AB is related to CD by definition. What is the definition? If and only if A plus D is equal to B plus C. Let me tell something. Sum of the extremes A and D is equal to sum of the means. Now, will it be an equivalence relation? Let us try to prove. Is AB related to AB? Sum of the extremes A plus B and sum of the means, that means Andarwala, that is B plus A, and that is true for natural number because A and B are natural number. That is true. Commutativity of addition. So this is reflexive. I am doing in short. Now let AB is related to CD. AB is related to CD. Sum of the extreme A plus D equals sum of the means B plus C. Can I write this as B plus C equal A plus D? Can I write this C plus B D plus A? So CD is related to AB. Just check it. Sum of the extremes C plus B, sum of the means A plus D are equal. So this is symmetric. For transitivity, let A be related to CD and CD related to EF. CD related to EF, where A, B, C, D, E, F all are natural number. Here it will be A plus D equal B plus C. Here it will be C plus F equal D plus E. Now if you add these two, what you will get? A plus D plus C plus F is equal to B, C, D, E. Now C, D would be cancelled out from both the side. So A plus F equal B plus E. So AB is related to EF. AB is related to CD, CD is related to EF, AB is related to EF. This means, this implies. So the relation is transitive. Now, can we extend this problem? What is the equivalence class of 2,5? Find the equivalence class of 2,5. How you can proceed, how you can make it. This is a homework and this is the end of today's class.